everyone. Welcome to this week's episode of ClueCon Weekly. Joining us this week is an old friend of the podcast and an esteemed engineer from Cisco, Richa Daga. She does embedded work at Cisco. You've done it for a long time now, and you've been around. You won a couple awards recently. Her 23 Women Professional Award in India, winner of the Women's Tech Global Conference Speaker of the Year Award. You have a big resume. So thank you for joining us.
Yeah, thanks, Luca. Thanks for having me here. It's about after 2 years that I'm back on the ClueCon Weekly show, and so glad to be here again.
Absolutely. So, would you like to give us a quick introduction about yourself before we start?
Yeah, sure. So I'm Richa Daga. I'm a global technical speaker, as Luca just mentioned, and also an international best-selling author. So as a software engineer at Cisco, I work in the development of products that are basically pioneering the breakthroughs to build the internet of the future. And apart from the exciting work technically that I do, that is, I'm passionate about chipsets and technologies that are connecting the world. I'm also a technical speaker at various conferences, such as Suboptic Conference, that is on submarine networks, IoT Slam conferences, that is the world's largest community of IoT practitioners, then Women in Telco, Women in Tech, and I also gave a technical talk on Grace Hopper Global Conference. And apart from that, few other IEEE events and Nuco podcast, then the ClueCon Weekly show that I last came about 2 years back. And plus the awards, before me mentioning, even Luca mentioned about it. So I won the Global Conference Tech Speaker of the Year award last year. This year, I'm a finalist in ERG Leader of the Year award. So ERG is Employee Resource Group. So another exciting thing, Luca, that happened after we last talked, I am leading the Cisco WISE India, that is Women in Science and Engineering Inclusive Community. And
Wow.
for all the work and the initiatives that I take under promoting women in STEM inside and outside the organization, I became a finalist for the ERG Leader of the Year award this year. And another thing that happened, I got a published author. I became a published author, invited as a global women change maker to share my story that got published and is available on Amazon and become a bestseller. So these are a few of the things that I can mention that more that got developed.
Oh, you you certainly got busy. You didn't sit around.
Yeah.
Oh,
Yeah.
congratulations on everything. So, what a more so everything is so interesting. So we have to start from somewhere. I'm curious. You mentioned optical networks, and I'm not even sure. This is a honest question. It's not a host question. I don't really know what that is. Like, what is an optical network in today's engineering? I know what fiber optic is, but that's probably slightly different.
Yeah. So it's kind of, yeah, optical networks is the fiber optic networks only. So you are very, very close to it. So that's how data transmission happens over the optical fibers. And when I talk about that, I am in the, I'm passionate about things that are connecting the world and proudly saying that we are the team building the internet of the future. So that's where optical networks come into play as the terrestrial optical fiber networks and the submarine optical fiber networks that we talked last time also. And on the optical networks, I'm really happy that now I have worked upon different areas of the optical networks, like the data when before it goes over the optical fiber, there is a lot of data transmission and multiplexing of the different bits that take place because there are different optical channels where wavelengths go into. So that is a kind of different hardware that is there. Currently, I'm working on optical line systems, which comes into play when the data is flowing over the optical fiber. And how the transmission happens is basically, if in a layman terms, I can say that when data is going over the optical fiber, there are some losses that occur because you just cannot send out data and bits of information without they getting attenuated. That is, they lose their power and because of the dispersion that happens. And there comes into play the role of optical applications. So I'm currently working into optical line systems and the optical applications where we do all our coding and to enable the hardware so that the data moves over efficiently and has a greater reach with the help of amplifiers that come into between and optical transmission. So I can go into more detail, but would like to hear from you further.
Yeah. So the I would say what's really interesting is how does this make the Internet of Things better or more doable? Is it just bandwidth, or is it also the speed of transmission? Like how much faster is that compared to using copper networks or satellite or whatever?
Yeah. So yes, like you actually came to the exact point that the optical networks is kind of enabling, because with the rise of bandwidth, with the rise of all the bandwidth requirements that are coming in because of a number of technologies like industry 4.0, we are talking about IoT, then we talk about AI, ML, edge computing. People talk about different technologies, but then they also talk about data, that yes, that data analysis has to happen. But one can be analyzing that data only if you are able to get it within time. So if we talk about like autonomous cars, that quick decision making has to take place. Like there's a car in front of you, and it is analyzing. Okay, with the help of sensors, now a decision making has to happen with the help of the cloud or the edge. Now, if the data does not go over in time, then decision making cannot happen in like in ultra low latency. So that is the term that IoT comes up with as one of the pillars of 5G also, that ultra low latency. And for IoT also to work, we should have communication that is high speed so that data analytics can work faster. So here comes optical networks which are supporting faster data transmission, because they are enabling the backbone, that is the wireline network, and enabling the core infrastructure and our data centers so that data transmission can happen faster. And now we are moving up to terabits of speed that is being enabled with the advancements of technology.
I see. So that's a twofold issue. Earlier, you mentioned amplifiers and the power of the signal, etc. So, does someone from outside will think that since light travels very fast at the speed of light, you will need any amplifiers, etc. So, how does a light amplifier work? First of all, that's another very interesting, because I know what an amplifier for electricity is. You add power to the wave. So what's an amplifier for, and why is it so important, and how does it work? I'm curious, actually.
Yeah. So amplifier, so it's like light is basically what photons that are traveling. If we go into our atomic concept of photons of light, so they lose their energy as they travel. So that is why if if someone would have heard the word about Raman effect. So that I used to study as a student in physics, but that is actually amplifiers. So it was Raman effect that happens that our atoms, they get excited and they move to a unstable state if we excite them, and then when they come back to a normal, to the ground state, they release energy. So that's how when they are releasing energy as light, amplification happens. So there are two kinds of amplifiers that we use. That is erbium doped fiber amplifier, that is EDFA, and the other amplifier is the Raman amplifier, which is able to amplify. So if our EDFA is not able to do the amplification that we need, we bring in Raman amplifiers as well. So these are two categories of amplifiers that get deployed in our optical communication systems.
Hmm. So it's the same principle as a laser, essentially.
Yes, you excite the atom with the laser.
Re-exciting. Cool. That's super. That's super interesting. So, well, so yeah, you mentioned you are a author and a best-selling author. So I'm very curious about your author's journey and how you got to write a book.
Yes, so since I have been speaking into various global conferences and having delivering different technical talks and creating a kind of a global impact as a women change maker, so that's where I was approached by a publisher who was coming up with an anthology of a book of various global women change makers, and there I contributed my story and contributed an entire journey of mine as a kid, then going into the technical field and coming up with the various, like working into this networking domain which I so much love, and about all the women in tech initiatives that I'm taking. So it's kind of a autobiography, which can say, which became an international best-selling book on Amazon as well.
Nice. Well, congratulations. Well, Risha, thank you for joining us today. It was a pleasure having you, and I'm sure we'll have other chances to meet maybe at some conference around. And we'll put
Sure.
the link to the book in the description, and also book to a link to your biography in the description, so people can come ask questions and go check your book. And thank you very much for joining us today.
Yeah, thank you so much, Luca. Thanks for having me on the show, and it was absolutely amazing to talk to you this time. As amazing as it was talking to you the previous time as well. So
We'll do
thanks
it
for
again
having me at the
and sooner.
ClueCon.
We'll do it again and sooner. So thank you,
Yeah,
Risha
sure.
Daga from Cisco, embedded engineer at Cisco, joining us today. We talk about optical networks and her journey as a speaker and book author. And well, thank you. And for the rest of the people, I'll see you next week. Bye.